When we use the phrase farm to wall, it's actually referring to one of our projects. It was the very first time where the straw that was used, the bales that were used to build the building, were actually grown on site. So it's sort of a play on the farm to table agriculture movement, where folks will have either a dinner event at the farm or very close by. So in this case, it was our first example where we were able to use the straw grown on site, and we literally picked them up from the field and put them in the walls of the building, which was quite a fun experience. We were inspired to start our firm for a number of reasons. We knew at the time that green building was really beginning to take off, and Annie and I both came from a strong background of environmentally sensitive design and had made some connections. We were part of the founding of the California Straw Building Association, which was using this agricultural byproduct as a building resource, and just felt like this was a wave that we wanted to ride, and not only do this work of deep passive solar integration of renewable energy systems, these environmentally friendly building materials, but actually wear it on our sleeve and make it the hallmark of what we were trying to do.
Arkin Tilt Architects was the product of a marriage, I guess you would say. My partner, David Arkin, and I were both working for different firms and had very shared ideas about putting sustainable design out there. The firm that I had worked for practiced passive solar design, made design decisions based on these, but they didn't want to talk about it. That's not what they wanted to say. It was sort of subversive. And I'm like, no, you got to get this out here so that people understand it, so that we can share how it's done and how it makes a huge difference in how buildings are shaped. It took a while for us to actually establish our own firm, but that was the goal from the beginning, was to really have green design be at the forefront. Good design and green design.
So sustainable architecture matters on all sorts of different fronts. In the last 2-3 years, I would say we've kind of made it about carbon sequestration, drawing carbon out of the air using bio-based materials. But from my own standpoint, because that's a relatively recent narrative, I'd say it just feels better. Walking through a straw bale building as opposed to a wood-framed concrete building and steel, it feels warmer, it's more personable. If you're using site elements to build your project, you feel ownership over it, you feel like your own, sweat, blood, and tears went into that project, and I think that really makes a building feel more like a home.
It's fun the way that straw bale is often referred to as, oh, that's a straw bale house, when in many ways it's simply the exterior wall system. And, houses still have to have foundations and roofs and doors and windows and electrical and plumbing and things like that. But there is a mystique around the fact that you are insulating your walls with straw, or in some cases, and this would be the load-bearing style, where the bales are stacked up like big fuzzy bricks. But I think what is really attracting folks to straw bale is the performance of it, the feeling of it. It's a very affordable way of achieving a thick wall, and there's a feeling of solidity that comes with that thickness. The play of light off the deep window and door openings is a very attractive feature of it. The high insulation level. And one of the things that's, undersold is the thermal performance of the thermal mass of the wall. That it takes 12 hours for the temperature to transfer to the middle of that straw bale, which means that if you have high daytime temperatures and low nighttime temperatures, the average and the interior of the building will stay right in the comfort zone as a result of that thermal mass, with proper shading and passive solar considerations and things like that. So it can be a big part of a high performing building envelope. One of the things that we're trying to do with our work is show that it can actually have a very modern, a very clean aesthetic. It doesn't have to be what a lot of people perceive as, a hobbit house or something like that. As one of the founders of the modern straw bale revival likes to say, you can do anything with straw bales except have skinny walls.
What keeps me excited about straw bale is, well, in the beginning it was really the thermal performance, the acoustic performance, the fact that it's a waste material, really, and they were, by burning it off of the fields, creating pollution. So again, as an environmentalist, it seemed much more sensible to put it into buildings. And then you get a natural, healthy building envelope. But what keeps me excited these days is that there are more and more systems being developed to use the straw. Very few homeowners are going to hire an architect and design their own home. So how can we provide these healthy buildings? There have to be different avenues, and there are different people working on that. We have a straw bale program where we design buildings for people just to get to permit, and it's a sort of simpler set. It costs much less. And then we take that design and make it available to people online. That work has already been done, and then they can put that into place. So that's one method. And then we're working on some other modular pieces. So part of it is from a design perspective, making different choices that can save you money. But in the end, I think there's a lot of different avenues to that. So now there's modular, a panel-based version, or you have a post and beam version, or you do load bearing. It isn't like there's one way of doing it, it's just a material. And how can you take advantage of that?
A lot of our work these days in particular is understanding the embodied carbon impacts of construction. That is simply, what are the materials made of? What was the extraction of the raw resource, the amount of energy that goes into the processing, where did that energy come from? For us, the straw is an agricultural byproduct growing as a plant, and I would apply this to all bio-based materials, where as they're growing as a plant, they are pulling carbon dioxide out of the atmosphere, releasing the oxygen, and locking that carbon away. And if we can build buildings with that carbon, and if there's anything we as humans are going to continue to do, it's build shelter to meet our needs. And I'm not just talking about Arkin Tilt Architects now, I'm talking about all of the architects and all of the builders. If we can use these resources and lock that carbon away in our buildings, then those buildings can become the Earth's 6th carbon sink. There are 5 natural carbon sinks, and I think this is the next one.
Vectorworks is working on a lot of different levels for us. It allows us to create a wall type that is very atypical, an 18-inch thick one, and there's a 15-inch thick one. So we're creating our own wall types, which we can put in our library. This is incredibly helpful. And then the addition of being able to do carbon accounting based on the materials. It's just been a boon for us because we can be talking about these things and we have some intuition about it, but to be able to put numbers behind it has been tremendous, right? We can say, oh, if you change this concrete foundation to a pin type, look, you can save this much carbon. And then it helps people make design decisions, right? It helps the clients. It gives them the tools that they need rather than us kind of hand waving about it and they're like, yeah. No, we actually have hard data. So it obviously takes a little bit more work to get that information in there, but because it's now part of our wall types, it's a much easier translation. So I think it's been tremendous that way.
Now that we've built kind of standard library of walls and floor styles, doors and roofs, all that stuff has materials now built in, inherent in those elements. And so now it's very easy for us to use Vectorworks Embodied Carbon Calculator to spit out a number, at least for A1 through A3 in LCA analysis. For those, just the product and construction portions of LCA, it's very useful as a comparative tool, right? So if the client comes to us and they say, we love the earthen slab, we want that in our project, but we're thinking about leaning towards concrete because it represents a lot less labor and the contractor's just more familiar with it, it's more of a known quantity, and we're interested to know what the environmental impact would be, right? And so it was a 10-minute task to go in there, replace all the slabs that were earth and clay with a regular concrete 3,500 PSI slab, and then show them the difference there. It was 8,000 pounds. We're imperial. I don't know the metric off the top of my head, but it was 8,000 pounds of CO2, and I was able to, just quickly convert that into gallons of gas and say, okay, well, switching from earth to concrete represents basically 430 gallons of gas. So that's driving to New York and back twice, right? So it's not a minimal increase. It's a very real number. You can put that in context and into something that people understand, and I think that's been super helpful.
What we're trying to achieve with our projects and what we really look for in the design opportunities that we take on is a marriage of what you might call, good design and green design, where the goals of high performance, zero net energy, ideally we're getting into carbon storing with our building materials, when we can bring all of those together. So it's, strong design in whatever style it happens to need to be in based on the goals of the client, but really trying to bring those things together and show that, good architecture is the combination of as many of those factors as possible.